let's test the valid transactions function we just created within the transaction pool. We'll do so within the testing file for this, within transaction-pool.test.js. Since we last edited this file, we actually wrote a feature that we can use to shorten down on the number of lines that we're using. Recall that we created a function within the wallet class that allows us to create a transaction based on a given address, amount, and transaction pool. The create transaction function within the wallet also does the job of adding the created transaction to the transaction pool. So this is what we're doing manually by creating a new transaction and then updating it and adding it to the transaction pool over here. So let's reduce this with a wallet.createTransaction call that does the same thing. So we'll say transaction is now equal to wallet.createTransaction with the identical inputs. So let's copy this random address, which is the LeetSpeak code for rand address. And then we'll have a 30 for the amount input. And then this time we'll also have our TP transaction pool instance as the final parameter to the create transaction function. Now that we're using wallet.createTransaction, we can remove the previous two lines, which essentially do the same thing, just expanded out more. All right, now we're ready to begin testing the valid transactions functionality. Let's create a situation where there is a mix of valid and corrupt transactions for us. Let's capture this with a scenario in a describe block that says mixing valid and corrupt transactions. And then we'll have our second parameter, which is the arrow function, to actually hold our tests. The goal of this block will be to create an array of valid transactions that is a smaller subset, or in other words, a part of the overall transaction pool that consists of only valid transactions. So we'll make our pool have both valid and corrupt transactions, but then we'll also have an array that contains only the valid transactions from the pool. That way we can use a valid transactions function and then check whether that returns the valid transactions array that we have stored. So as such, let's define a valid transactions variable that we can use within our tests. Then before each following test in this block, let's set up the valid transactions. So we'll have our before each block. To begin, any test in this block will actually, because of the original before each block that generates one transaction, will already have one valid in the pool. So we're going to assign the valid transactions variable to a new array that already contains the valid transactions, which we can do by saying valid transactions equals an array of spreading in the elements of the current transactions within the transaction instance. So the spread operator takes all the elements of this transactions array of the TP instance and then adds them one element at a time to our valid transactions array. Now let's do the job of generating valid and corrupt transactions in this before each block. The strategy will be to run a loop about 6 times or as many times as you want. And every iteration of this loop will set the instance of the wallet to a new one. That way, every new wallet will generate a new transaction to an arbitrary address with an arbitrary amount. However, this is where the corruption comes in. Half of the time, if we're in an even numbered loop, we'll corrupt the transaction by changing the input amount to something absurd. In the other half of the loops, we'll add the transaction to the valid transactions array, since that one will be a valid transaction in the pool. So let's create our loop that goes 6 times. So for let I equals 0, I is less than 6, I plus plus, and this is the for loop in JavaScript. We'll reset the wallet to a new instance of the wallet, so that way we can create a new transaction. And then our transaction will now be a wallet.createTransaction call. Again, we'll copy a rand address, or we can type a new one out, r4nd-4dr355, looks like rand address in LeetSpeak. Then we'll provide the amount, which is 30. And then finally, the last parameter is the actual transaction pool, which is TP. All right, now we'll check if we're in an even numbered loop, which we can do by saying if I%2 or mod2 is equal to 0. In other words, if I is divisible by 2 and an even number, and that remainder is 0. Then we're going to corrupt the transaction, so let's set the amount in the input to something absurd like 99999. Otherwise, we know that the transaction is valid, so let's acknowledge that by pushing this transaction to our valid transactions array. So in the end, about half of the transactions will be corrupt because of this line, which sets the amount in the input to something absurd, and then the other half of the time, we push the transaction to the valid transactions array. Excellent. This should make it so that transactions in the pool consist of transactions that are both valid and corrupt. For the first test in this scenario, let's prove that there is a difference between valid and corrupt transactions in the first place. So we'll say it shows a difference between valid and corrupt transactions. Then we have our second arrow function as the second parameter. The test will expect that the stringified form of the transactions in the pool are not equal to the valid transactions variable that we have. We'll expect that if we json.stringify the transactions in the pool, that this is not equal, in other words, not to equal, the json.stringified form of the valid transactions array that we have. So in the end, you'll expect that the stringified transactions from the transaction pool are not equal to the stringified valid transactions. Likewise, for the real test of interest, we'll expect that if we grab the valid transactions from the transaction pool using the valid transactions function, this should equal this valid transactions array that we've now set. So we'll have a test that says it grabs valid transactions. The second parameter is the arrow function, and we'll now expect that if we call tp.validTransactions, well, this should now equal the valid transactions array that we've built. All right then, with those tests set up, one for valid transactions and one for proving that there's an actual difference between valid and corrupt transactions, let's now head to the command line and execute our testing script. All right, let's open up the command line and then run npm run test. And then as we do so, it runs all of the previous tests and it will pick up the new tests. And in this case, all the tests passed and everything went well. Also notice that we get in the console some messages that it invalidated 3 transactions because of invalid amounts from the bad wallet, which proves that the valid transactions function skipped over the corrupt transactions in the pool. All right, with the valid transactions functionality completed, let's move on to the next step in the miner's mine function, which is to generate the reward transaction for a miner.